is the solution for the mock exam for lines. Even though it might look long with 4 problems, the first 2 problems are pretty quick, not really too much calculation involved in these. So really the last 2 problems are the only ones that require any length of time. So even though it says 20 marks, I don't think it takes 20 minutes if you're up to speed. First thing it says, the gradient of several lines are as follows, and it gives you gradients or slopes of lines in decimal form, in fractional form. It's a mix, right? And so first I'm going to show you how to pick out some of the answers just by looking at the fractions. Remember that what we're going to do here is in part A, we're going to find lines that are parallel to each other. In part B, we're going to find pairs of lines that are right angles to each other or perpendicular to each other. And remember that you can find perpendicular lines easily if they're in fractional form. But I'm also going to show you how to do this with the calculator so that no matter what form it's in, you can figure out the perpendiculars and parallels. Okay? All right. So first thing, it says part A, find the 2 pairs of lines that are parallel to each other. And in this case, what you're looking for are gradients or slopes that are exactly the same, which seems absurdly easy, right? But unfortunately, since they put, these gradients and slopes in different forms, fractional and decimal, even though they're the same value, you can't tell sometimes, right? So my recommendation on this problem is convert every single non-decimal fraction into a decimal, right? So like, let's see which ones are decimal already. That's a decimal. Even though it's a whole number, it's a decimal. That's a decimal. That's a decimal. Everything else is a fraction. So it's hard to tell if they're the same number if they're not all in the same form. So let's look at the values of each of these by calculating them on the calculator. For example, -5 divided by 2, let's see what that is on the calculator. -5 divided by 2. It's -2.5. So I'm going to rewrite this as -2.5 right above it. What about 1/3? 1/3 in decimal form is 0.333. We're going to leave at least 3 significant figures. 3 divided by 6. That's 0.5. -2 divided by 5. That's -0.4. And 5 divided by -2. That is -2.5. Okay, and the others are already in decimal. Now let's look again and see if we see any matches. So I do see a match between this one and this one. Those are both -2.5. Any other matches? Let's see. Oh, there's 2.5s, right? There's like this 0.5 and this 0.5. We might not have seen that they're both 0.5 because one said 3/6, but once we put it in the calculator, we can find out that it is 0.5 also, okay? And B and G, a little bit misleading because one of them says -5/2, the other one says 5 divided by -2. It doesn't matter if the negative's in the top or the bottom of the fraction, it's the same thing, okay? You could pull either one of those out and put the negative sign out in front of the fraction itself, okay? But you can see, when you divide in the calculator, you can see that both are equal to -2.5, right? So the calculator kind of helps you figure out which ones are exactly the same. So the 2 pairs are B and G and D and E. Okay. Find any 2 pairs of lines that are right angles to each other, meaning they're perpendicular to each other. That's the symbol for perpendicular. The way we're going to do this is almost the same. Okay. First, I'm going to show you how if you are pretty good at identifying fractional values, you can look at certain pairs and already see that they are the negative reciprocals of each other. For example, if you look at A and C, you might see that, oh, this one's negative 3 over 1, this one's 1 over 3, those are upside down, and they are negative values, so they must be perpendicular, okay? So you might be able to figure it out in fractional form, and it might be an advantage to you. But I'm going to show you a method of using the calculator so that you do not need to reduce fractions or anything complicated like that. What we're going to do is we're going to take each one of these decimal forms. We already have the decimal form of each, and we're going to figure out what would be the perpendicular decimal value, and then we'll see if we can find it in the list, okay? So for example, negative 3, the perpendicular value of negative 3 would be negative 1 divided by negative 3, because remember, if we want to find a perpendicular slope, if we want to find a perpendicular slope, we take negative 1 over the original slope. So negative 1 over negative 3 gives us the perpendicular slope to negative 3. It turns out it's 0.333. Okay? And now we can already see that that 0.333 is the perpendicular for negative 3. So we can see that A and C are perpendicular pairs, right? What about the next one? So what would be the perpendicular to negative 2.5? So we say negative 1 divided by negative 2.5. And the answer is 0.4. Oops. And I think that we have a 0.4 in the list too, don't we? So let's see. We got 0.4. And we have, we have a negative 0.4, but do we have a point? Oh, we do. Okay, so H is 0.4. So it turns out that B and H are also a perpendicular pair, because if we put negative 1 over negative 2.5, we get 0.4, which is H's gradient, right? Now we've already seen that C is the perpendicular for A, so we're done with that one. And then D, let's see, what is the perpendicular for D? It would be negative 1 divided by 0.5, which is negative 2. Any negative 2's here? Negative 3? No, nothing that is negative 2. What about 0.5? Well, we've already done 0.5. We already know that 0.5, the perpendicular is negative 2, and we know that there's no negative 2. What about negative 0.4? What is the perpendicular of negative 0.4? It would be negative 1 divided by negative 0.4, which would be 2.5. Are there any values of 2.5 here? No, there's negative 2.5, but there's no 2.5. So no perpendicular to negative 0.4. What about negative, we already did negative 2.5. Negative 2.5, we already know that the perpendicular is 0.4, and we already know that H has 0.4, so G and H are also a possible pair. And I'm gonna, let's see, I'll put negative 2.5, 0.4, 0.4. So those are also a possible pair. And of course, if we would do negative 1 over 0.4, it would just give a negative 2.5. We would discover something that we already know, that H is a perpendicular of G and H is a perpendicular of B. It says find any two pairs of lines. So you could put any two of these. You could put A and C and B and H. You could put B and H and G and H. You don't need to put all three as the answer for this one. Okay? All right, next one. See, that didn't take too long. Number 2, the following diagram shows 6 lines with the equation of the form y equals mx plus c, and they are all just diagrams with no numbers on them. You might say, how am I supposed to know what the equation of these lines are if there's no numbers? But let's take a look at that. So remember that the m and the c here each have a significant significance if you look at a graph, because m is the gradient and c is the y-intercept. So we can see, depending on the value of m and c, maybe which of these pictures an equation corresponds to. And now in this case, they didn't even give us equations. They gave us conditions where they tell us that m is positive or negative, that c is positive or negative. So that might seem difficult to do without any numbers on the diagram, but let's try it out and you'll see that it's not so hard. Okay, so let's look at the first one. It says, find the diagram where the slope is positive and the y-intercept is positive. So y-intercept is positive would be the line crossing this part of the y-axis, right? Which this one doesn't. So let's see. Y is positive. This one. Isn't that y is positive? Because it's crossing in the upper section of the y-axis. This one, y is positive. Okay, those are the only two with y is positive. Now, which one of those two has a positive slope? This one here, right? Because it looks like the economy for Brazil is improving. So we're going to say that the answer is L5. Okay? All right. Let's look at the next one. The next one says the slope is negative, m is less than 0, and c is greater than 0. Oh, that was the other one. So this one has a positive y-intercept and has a positive slope. This one here has a positive y-intercept and a negative slope, right? And that's exactly what we want here on this one. Negative slope and positive y-intercept. So I know that this one is going to be L4. Okay. What about the next one? It wants a negative slope and a negative y-intercept. So let's, instead of looking for y-intercepts, let's look for slopes. So you can see that you can actually look for it another way. I can see two remaining graphs where the slope is negative. These two, the slope is going down. Looks like the economy of Brazil is getting worse. So in these two cases where the slope is negative, now I just need to see which one has a negative y-intercept. This one has a negative y-intercept. This one actually goes right through the origin, so it's a 0 y-intercept. So I know it has to be L1. What about the last one? It says the slope is positive and the y-intercept c is negative. So now I'm going to look for one where the y-intercept is negative. So that would be this one or this one that we already used, and those are the only two possible ones that have a y-intercept that's negative. But we're looking for a slope that's positive. That would be this one here, where it looks like the economy for Brazil is going up. So that means that the answer is L3. See, that one wasn't too hard, was it? Let's go to the next one. Okay, number 3. The equation of the line R1 is 2x plus y minus 8 equals 0, and the line R2 is perpendicular to R1. They didn't give us an equation for R2, they only gave us an equation for R1. Calculate the gradient for R2. Okay, so is that possible to do? Well, they did give us one piece of important information. They said that R2 is perpendicular to R1. So if we only knew the slope for R1, then we could use the formula m perpendicular equals -1 over the original slope to find the slope of R2 from R1. But looking at this, can you figure out the slope? Now be careful. You might think, oh, 2x, so 2 is the slope. Be careful, because this is not in slope-intercept or gradient-intercept form. This is in standard form, where everything's on the left and 0 is on the right. We need to rearrange it so that it's calculator ready, so that it's in slope-intercept form. So let's do that. So we're going to first copy down what we have there, and then we're going to make it so that the only thing on the left is y, everything else is on the right. So to do that, we can add 8 to both sides, and we can subtract 2x from both sides, and that would give us y equals -2x plus 8. So now we have changed our standard form equation into slope-intercept form, gradient-intercept form, and now we can see that the gradient is clearly -2. It's not +2, it's -2. Okay, now we can figure out the perpendicular slope to -2, because we could just say, oh, the perpendicular slope is equal to -1 over -2. And if you want to figure out what the value is on the calculator, which is a little bit easier, we could put -1 divided by -2, and it gives us the answer of positive 0.5. So we know that the gradient of R2, which is perpendicular to R1, is going to be positive 0.5. The point of intersection of R1 and R2 is 4, k. Find the value of k. And you might say, oh my gosh, how am I supposed to know what the value of k is? I don't even know the equation for R2. How can I figure out the point of intersection between the two? Well, remember that if you know that you already know the equation of R1, it's that, right? And now they're giving you the x coordinate of this point, and we know that this intersection point must be a point on R1, so we could figure out what the y value is for 4. Okay, there's a couple ways you could do this. Let's use the calculator first. You could say y equals, and you could put the equation for R1, because in the process of figuring out the gradient of R1, we put it into calculator ready form. We'll put -2x plus 8 into the calculator, and we could graph it, or we could do table. There's a couple different ways you could do to find out what is the y value for the x value of 4. Okay, so I'm going to show you a couple different ways. First way is trace. We could do trace x equals 4, and then it'll give you that the y value is actually 0 at that point. So it turns out the value of k is 0. We could also see that by doing second table and checking the x value of 4. We could see that the y value turns out to be 0. Okay, and last of all, if you want to do it without the calculator, you could just substitute in the value of 4 into this equation. You could put it there, and it would be -2 times 4, which is -8, plus 8 equals 0. So you could do it without the calculator too. At any rate, the value of k is 0. Okay, so the point where the two lines intersect turns out to be 4, 0, right? Then it asks us for the equation of R2. And now you might be freaking out because you're like, how am I supposed to figure out the equation of R2? I don't know anything about it except for that the slope of R2 is 0.5. Well, you do know something, because they told us that the two lines intersect at 4, 0. Not only is 4, 0 a point on R1, it is also a point on R2. So actually, we do know two important things for R2. We know that it has a point, 4, 0, and we know that the slope is 0.5. And remember, if you have a point and you have a slope, you can easily find the equation of R2 using what we call point-slope form. And we're going to do that, okay? So point-slope form is on the formula sheet, and it looks like this. And we're just going to substitute in 4 and 0 in for x1, y1, and we're going to substitute in 0.5 in for m, and that gives us the answer. Y minus 0 equals m, oops, not m, because we already know that m is 0.5. We write 0.5. 0.5 x minus 4. Okay? And actually, this 0, you don't have to write it, so you could y equals 0.5 times x minus 4. Okay? And is this in the format we want? Well, it never says exactly what form to put it in. So you could put it into slope-intercept form, you could put it point-slope form, you could put it in standard form. It doesn't matter. If you'd like to multiply it out and get slope-intercept form, you can. You would just distribute the 0.5 to x and -4. But if you're not really sure about your algebra, you can just leave it like this and then not risk getting it wrong, right? So 0.5 times 4, if you do it in the calculator, you find out it's 2, so it would be -2. So there is an alternative answer. You could put y equals 0.5x minus 2, but either one of the first two answers is also fine. Okay, let's go to the next one. Now here, of course, is a Voronoi diagram problem, because they're definitely going to ask you a Voronoi diagram problem on the exam. So the pizza restaurants A, B, and C are located as shown in the grid map below. And the A and the B positions are quite clear from looking at them because they're at exact integer values of x and y coordinates. The C value is a little bit harder to see exactly where it is, so the C coordinates are provided, 6, 3.5. The line drawn on the grid is the Voronoi diagram border between A and B. And you can kind of see that because if you connected A and B with a line, you could see that this purple dotted line is perpendicular to the red line, at least visually, right? Okay. Find the midpoint between A and C. Okay, so we're going to find the midpoint between these two. And you could use the midpoint formula, but of course, we could use stat calc 2var stats. All we need to do is put the coordinates for A and C in the calculator. So the coordinates for A appear to be 2, 5, right? So we'll put 2, and then we'll put 5, and we put it across, not going down. And then we put C also in the calculator, 6, 3.5. 3.5. Okay, and then we're going to do stat calc 2var stats. And then we put L1, L2 blank in there, and we go down to calculate, and then we can figure out what X bar, Y bar is. That is the mean point. So it would be 4, 4.25. 4, 4.25. Next step. Hence, find the equation of the Voronoi diagram border between A and C. Remember, once you find the midpoint between A and C, and the A and C midpoint is at 4, 4.25, it's about there. Remember that now you have everything you need to draw the Voronoi diagram border through that point, because we're all ready to find the slope of the red line, which is perpendicular to the slope of the yellow line. Okay, so let's do that. We're going to, because the two things we need to draw the Voronoi diagram border in yellow is we need to fill in the slope-intercept form, or the point-slope form, which looks like this, remember. And the 4 and the 4.25 go in to x1, y1, because a midpoint is, of course, one of the points, one of the most important points on the Voronoi diagram border. And then we just need the slope. And the slope of the yellow line is perpendicular to the red line. How do we find the slope of the red line? Well, pretty easy. We go stat calc lin reg with the exact data that we already put in there. And it gives us, okay, L1, L2 blank, as usual. And then we're just going to hit enter with calculate. And then it will give us the slope value in the A field. So negative 0.375 is the slope for the red line, negative 0.375. So what is the slope for the yellow line? The slope for the yellow line is negative 1 over m. It would be negative 1 over negative 0.375, which is equal to negative 1 divided by negative 0.375. And the answer is 2.67. Okay, so the m value turns out to be 2.67. So I'm going to rewrite everything, and I'm going to put 2.67 in for m. And it said didn't say what format the equation should be in. So I'm just going to leave the equation in point slope form, just like it is there. Okay, then it says a new taco restaurant D will be built at a location exactly in the middle of these three pizza restaurants. At which coordinates will it be built? Well, actually, it turns out that the exact point that's in between these 3 points is the Voronoi diagram vertex that's right there. So the intersection of the yellow line and the purple dotted line. How do we find the intersection? Well, we just use second calc intersect. So we take the purple line, which turns out to be this equation here, and then we're going to find the intersection with the yellow line. And the yellow line equation, which is right here, unfortunately it's not calculator ready. So let's make it calculator ready by putting y equals by itself on the left side. So we'll do that. How we do that? We add 4.25 to both sides, right? And I wouldn't necessarily mess with anything else on the right side. You can go ahead and leave the right side as is, except for, just adding the 4.25 to it, because then you know that you're not going to have any algebra errors. So you could just leave y equals 2.67, parentheses x minus 4, parentheses, which was already there, and then you just put plus 4.25. So let's put that as our first equation. X minus 4 plus 4.25. And then for the purple dotted line, we know that we're going to use the equation that's given to us, which is negative 0.25x plus 3.375. Negative 0.25x plus 3.375. Okay, and then we graph it, and it's going to look kind of like the purple and yellow line here, except maybe a little bit out of proportion, because you can see that the y scale and the x scale on the calculator are not the same. So they don't look perpendicular, even though they actually are. No, well, actually these aren't perpendicular, so they don't look perpendicular either. So let's find the intersection point by doing second calc, intersect, which is option 5. And then when you're intersecting two lines, all you need to do is hit enter 3 times, okay? It's actually asking you, oh, do you want the blue curve? Do you want the red curve? Make a guess. But, you know, with lines, you don't need to be that careful about it. So it turns out that the intersection is 3.36. It's actually 3.3578, blah, blah, blah. But we just want 3 significant figures. And the y value is 2.54. Okay, so that's rounded correctly. It's 3.36, 2.54. And that's it.